Thank you. Okay, so let's start, I think. Welcome to the Crowd Science Seminar. These seminars cover a broad area of human AI collaboration, allow discussing past and future work, exchanging ideas, and establishing new collaborations. Today, Nikolay Babakov from Skoltech Institute of Technology will describe a new dataset on textual inappropriateness for Russian that impacts one's reputation. I'm giving the stage to the speaker.
Yeah, hello everyone. Today I'll talk about detecting inappropriate messages on sensitive topics that could harm a company's reputation. So this work was conducted in terms of collaboration between Skoltech Institute of Science and Technology and MTS company. And the results of our work were published on BaseNLP workshop in IACL conference, and you can read it on their official ACL website. We should start from defining the term of toxicity. Actually, the toxicity is the behavior which can offend, harm, or in any way make other participants of the conversation feel bad. Of course, in most cases, the toxic behavior is something about real living people behavior in different public platforms such as Instagram, Facebook, Contact, etc. For example, Instagram even deployed such a feature which intentionally hides the dangerous or inappropriate comments. So if you really want to unhide the comment, you should tap special button, and only after this you will be able to see this potentially toxic comment. But the problem is that not only people can be toxic. Machines can also be toxic if they are trained on the real-world data which was not properly cleaned. For example, there is a well-known case when the Tweets bot trained on such kind of data started to produce really bad stuff about Hitler and about hating everybody, etc. There also is another use case when Tinkov's chatbot received a message from the user who told something about fingerprint doesn't work, and instead of providing some reasonable reply, it answers, "I would have cut off your fingers." Of course, both of the cases were published, and both of them harmed the reputation of the company. So bearing in mind what I've just said, we now can state the problem we tried to solve in terms of our work. First of all, of course, we understand that toxic utterances are often harmful to user experience and require some censorship. But the harm to user experience is not the only problem which can be yielded to by toxicity. Another potential harm from toxicity is reputation loss for the company which deployed the dialogue agent producing some unacceptable utterances. And the reputation loss can be yielded not only by toxic utterances, but also by other kind of utterances which have not been formally classified and collected before. We name such utterances unacceptable. And in the next slide, I will show you some examples of inappropriate utterances. For example, let's imagine that the user opens the dialogue agent and writes something like, "I want to watch Lord of the Rings." And dialogue agent answer, "Just download it from torrent." Of course, it is not okay for us because it directly proposed to the user to break the law. And this is, of course, unacceptable. At the same time, dialogue agent can say something like, "You could download it from torrent, but I prefer respecting author rights and buying films from legal services." This phrase is still related to sensitive topic, but it is easy to understand that it is appropriate because it can hardly anyhow damage the reputation of the company. And we can make up different examples of such imaginary dialogues. For example, about religious people, of course, most of us know that you should be extremely careful in Russia when talking about religious people. So, for example, if our dialogue agents will say something, it's not clever to believe in some imaginary stuff living somewhere in heaven, the company will definitely have the problem. But in the same time, it is possible to say something neutral about religion, and it will be okay. So here is some visualization of what we tried to collect in terms of our work. Well, as I said, there are many different kinds of utterances potentially produced by dialogue agent, which can harm the reputation of the company. Of course, everything which is toxic is harmful, but toxic is not the only stuff which can harm the reputation. So we tried to collect this stuff which is not toxic but still harmful. So we want to be open to any topic, even if it is potentially sensitive or dangerous, and we don't want to block the mention of this topic by some like keywords. But in the same time, we don't want to give away to provocative or harmful utterances about any sensitive topic. Of course, there are a lot of different researches dedicated to inappropriate speech or toxicity. There are such classification approaches as by types of insult, for example, obscenity, threat, identity hate, cyberbullying. Of course, different sensitive topics have also been studied, such as sexism, racism, LGBT, and the inappropriate speech was also classified by other properties such as direction or explicitness. Generally, our work consisted of 2 steps. And the first step was collecting the as exhaustive as possible sensitive topics list. We collected 18 topics. They can be roughly split by 2 groups. The first group of topics is indirect toxicity or unfair generalization. In terms of this sensitive topics list, people tend to offend someone according to some property related to the group. For example, offending religious people, offending people because of the properties of their body, of their health, or of their race, etc. Another much bigger group is harmful practices. It consists of such stuff like gambling, prostitution, slavery, different kinds of crimes like murder, physical assault, or breaking passwords and accounts, pirate content, and terrorism or weapons. So really broad list of topics. After we defined the list of topics, we started collection of the data set. So the most intuitive approach for this was using crowdsourced worker from Yandex Toloka. But there was one obvious problem. The number of sensitive topics. For regular crowdsourced worker, it is really hard to handle all 18 topics at once. That is why the annotation was performed 3 times for similar text, but for different topics. Maybe some of you can guess what potential problem can this approach yield in terms of annotating the really big data set. Do you have any ideas, maybe? Okay, I'll answer this question in the next slide. First of all, I'll show you the groups we defined for the annotation process. The exact content of each group is not obligatory. We just iteratively understood that this kind of groups will yield least possible amount of problems in terms of annotation process. Well, and the first issue in terms of this annotation was that we naturally had to split the annotation within 3 independent projects. So we naturally must have sent 1 sample to 3 projects and to 3 independent annotator. So this tripled the expenses per sample. And this was really a big problem. Another problem was that the crowdsourcers tended to overthink sometimes. I will try to show you the intuition of this problem. Let's imagine that we are annotating the samples in the project which asks us to tell whether or not there is a mention of one of these topics: religion, terrorism, racism, other crimes. Other crimes is all about murder, kidnapping, and violence. Crimes in the virtual space, it's about downloading from torrent, pirate content, etc. Drugs, tobacco, alcohol, or none of that. So let's imagine that on the first page we have samples similar to this one about Kalashnikov gun, and we say, okay, none of the topics are related to this sample. And for example, we go on annotating, and second and the third page still has the similar samples. And none of the samples are related to any of these the list of proposed topics. On the fourth page, the annotator starts overthinking, which actually means that, okay, it is probably not possible that none of the topics are related to the proposed samples. So maybe if this sample is about machine gun, so you can guess that it is somehow related to other crimes, about some killings, etc. So of course such relation is possible, but it is withdrawn from really fine details, and this is not what we want from our annotation process. Another problem is literal perception. This problem is most easily shown by the word whore. Sometimes it is located in the sentence, which is really about prostitution stuff, but in the same time it can be inside such a sentence which is not anyhow related to prostitution, but the not really hardworking annotator can simply capture this keyword and immediately select the corresponding and not necessary for us sensitive topic. Yeah, this was the main issues we faced during using Yandex.Toloka for such a big amount of labels to be annotated. That is why, after collection of nearly 10,000 of samples, we tried to use some alternative approaches. The first alternative approach was in training multi-label classifier on crowdsourced data. What we actually did is using the 10,000 samples collected in the previous step and inferred the model on new texts. The model made some predictions. In most cases, they were reasonable. And we manually checked the prediction and finally selected the topic which was actually correct. So, of course, this is human labor, still human labor, and it requires engagement from our side, but it is still easier than annotating from scratch. Another alternative approach we tried to use was in alignable keyword search on specialized forums. It means that we, for some topics, such as drugs, for example, we somehow found the list of keywords, and we also found the specialized forums. We parsed the content from these forums, and using these keywords, we collected the sentences with these keywords, and finally we manually checked the actual relatedness of the collected samples to the necessary topic, and it was of reasonable quality. So this approach really helped us. Yeah. So finally, our sensitive topics dataset was collected by 3 ways. So Yandex.Toloka, self-labeling after the model can be pre-trained, and in alignable keyword search from specialized forums. Do you have any questions about the process of annotation of sensitive topic dataset?
Is the question? Sorry.
Yeah, I will go back to the overview of the whole pipeline in the end, so maybe you will have other questions in the end. Well, now I'll talk about the second step of our work, which is actually the core part of the work. This step is dedicated to collecting of appropriate and inappropriate utterances in terms of sensitive topics. As I said before, even though the utterance is somehow related to the sensitive topics such as offline crime or religion or prostitution, there can be some appropriate utterances. So for example, if we say something like killing is not a big deal, it is of course inappropriate. So, but if we say something like this is a violation of the criminal law, it is appropriate, and it is okay for us if dialogue agent somehow changes the effect of breaking the law. So this was the so-called substance we tried to collect in terms of this dataset annotation. So the main sources of this dataset was first of all already collected sensitive topic dataset, and such popular resources like Dvach, Ответы Mail.ru, or Peekaboo. The preprocessing consisted of masking numbers, URLs, and nicknames, and we also explicitly skipped the samples with obscenity and with automatically detectable toxicity. We also trained multi-label sensitive topic dataset on already collected dataset, and we tried to have we tried to have the same amount of sensitive topics in samples in terms of the collected dataset. For annotation itself, we tried two different setups. The first setup was binary annotation. In terms of binary annotation, the worker handles one utterance within one annotation sample. It is really easy to implement in Yandex.Toloka, but in terms of our task, it could sometimes be not very obvious. Preparation for binary annotation includes such steps as forming pools which can prevent the bias. What I mean by preventing the bias is that we should not put samples related to, for example, downloading some stuff from torrent and related to violence on the same annotation page, because in such case it can prompt the worker to make an unintentional comparison, and he or she can mark the downloading from torrent as appropriate and violence inappropriate, and this is not what we actually want from the final dataset. And another preparation step is making control and training tasks. And the results were calculated with David-Skin algorithm, which is embedded to Yandex.Toloka. The second alternative approach for annotation was pairwise comparison. The worker should compare two utterances within one annotation sample. And this, by our hypothesis, could have disambiguated inappropriateness in some cases. This approach required a little bit more preparation steps. First of all, we should have manually sorted samples into three groups, like definitely dangerous, can be dangerous, or cannot be dangerous. It was necessary to initiate the reasonable pairs to be compared. And we also prepared control tasks and training tasks. Pairwise comparison also required some intermediate steps, because when we send the first group of pairs to comparison, it is still not enough to call it good results. So after the pairs are compared, we should use some algorithm to select new pairs which will maximize the potential information of new comparisons. And when we run out of budget, we stop annotation and we should aggregate the results into ranked lists. Well, here you can see the examples of the results of both approaches. This is the result of what we get from binary annotation after David-Skin algorithm calculates the inappropriateness score. And here you can see the results of ranking of pairwise comparison results. In terms of this setup, the sample doesn't have any original score. It just has the position. Score still can be calculated, but it is rather a function of the position. Yeah, so the results look like that. We needed to select the best annotation setup, which is better for our specific task. What we actually did is we first of all manually annotated on our side the samples within 4 groups: exactly okay, closer to dangerous, and definitely dangerous. And then we compared the final confidence obtained by the aggregation algorithm and the resulted group obtained by annotation on our side. And this resulted into the score, which can be the value from 0 to 1. According to this score, we could calculate the agreement score by the number of evaluated samples. And we found that both of these approaches has nearly similar quality. So this was not enough to make the decision. Another point of view for making the decision was the availability of Yandex Toloka tools for each of these approaches. For binary annotation, everything can be done within Yandex Toloka without any need to do something out of this platform. We could have done training of the workers. We could mix some control tasks into the real tasks. We could also create an interface for specific task, and we use the David-Skin aggregation. For pairwise comparison, everything except built-in aggregation was available. And we also should select the best pairs for comparison on our side. So probably it could be something like a feature request to Yandex Toloka developers. Well, this is the table of our where we try to show all the reasons upon our final choice. For binary annotation, the obvious pros was that it is easy to implement in terms of Yandex Toloka. The cons is that the answer within a single sample is not always obvious. But Yandex Toloka provides a good tool which helps us to easily address these cons. The tool is named Dynamic Overlap. It helps to increase the overlap for samples with an ambiguous response. In the same time, the pros of pairwise comparison is that it increases the accuracy of the answer to markup question. But at the same time, it is harder to be implemented because we need to do some stuff out of Yandex Toloka. And what is most important, that if we merge all the topic into a single dataset, this will significantly increase the costs. For example, if we want to have the dataset of some like 100,000 samples, we will need to, even if we use some clever algorithm for pairwise comparison for selecting the best pairs, we will still need to perform a lot of comparison, and this will yield enormous expenses. And another important point is that if we combine such topics as downloading from torrent or terrorism in the same dataset, the pairwise comparison will push the downloading from torrent in the bottom and terrorism in the top. And this is not the behavior which we want, as I previously said. We want that the score of really inappropriate stuff, never mind what exact sensitive topic it is related to be the same. Yeah. So we didn't find any reasonable way to address the named concepts, so we decided to use binary annotation. Well, let's have a look at the overall datasets collection pipeline. As I said, we used such sources as Ответы Mail.ru, Dvatch, Peekaboo, or specialized sources, specialized forums. We performed pre-processing by masking URLs, nicknames, and some other personal data. We then used Yandex.Toloka for collecting 10,000 of samples for sensitive topic dataset. Then we trained the model and annotated several thousand of samples by ourselves. And in the end, we used a keyword-based selection. When we had some more than 33,000 of samples, we started to collect the appropriateness dataset, except the already named pre-processing. We also got rid of the samples with obscenity and with toxicity. And then we used already trained multi-label classifier to keep the balance of the top of the samples related to all of the 18 topics. And after that, this was sent to binary annotation to Yandex.Toloka. Now we can have a look at the statistics of the collected dataset. So we collected more than 163,000 of samples for inappropriateness dataset, and more than 48,000 were related to inappropriate utterances. It is also worth mentioning that not all the samples collected within this dataset had the highest confidence. I will show you later that the higher the confidence of collected samples, the higher the metrics can be obtained by the model. So that's why I show you that within these 163,000 samples, there are 106,000 samples with higher possible confidence. Yeah, and for sensitive topics, we collected more than 33,000 samples. On this slide, you can see the proportion of the appropriate and inappropriate samples related to any of 18 sensitive topics. And here are some crowdsourcing statistics for both of these datasets. Some interesting insights in terms of crowdsourcing is that the annotation time for sensitive topic is quite high, bigger, because even though I believe that the main reason is that the user should have selected within 6 variants. So this yield spending more time for one for annotation of one sample. Yeah. So Of course, we tried to train some models on the collected datasets. We use some regular baselines, and we also tried to use some nearly SOTA algorithm. For example, we used fast text with convolutional neural networks, and we used the conversational Rubert from Deep Pavlov, which is available on Hugging Face Model Hub. So the model which demonstrated the best results for sensitive topics dataset was conversational Rubert. And here you can see some statistics about the metrics for each of the sensitive topics. On this plot, you can see the relation between the number, between the count of samples per sensitive topics and the final metric, final F-score, which we can obtain by training the model on them. Of course, if there are a lot of samples, the metrics will also be quite good. But in the interval between 1000 and 2000, we can see that it is not always the case. So even if you have some more or less reasonable amount of samples, you still can get not really good metrics. For example, in case of politics, the most possible reason for not really good metrics is that we defined the topic really broad. The politics includes such stuff as territorial conflicts and military service, and the real politics like protests, election, etc. We thought about splitting the politics into several topics, but finally we decided not to do it because 18 topics is already really big amount, and it's not so easy to handle this number of topics. Yeah, and the metrics obtained for inappropriate utterances showed more or less similar behavior of models. The best model was also conversational Rubert, and we also tried to somehow use the information about the definite sensitive topic which the sample is related to, and we got a slight improvement on the metrics. So as I said you before, the confidence of collected sample is highly related to the metrics of the trained model. So on this plot, you can see this relation. And in this table, the metrics with the 100% confidence samples is shown. Well, finally, I want to say that this data can be used in real-world tasks. But what I want to emphasize is that the substance we try to collect is not a substitution of toxicity. It is rather a derivative of toxicity. So the model based on our dataset could serve as an additional layer of inappropriateness filtering. So for example, if you want to deploy a chit-chat dialogue agent, and before you send some real-world tech data for training this dialogue agent, you of course still have to get rid of obscenity and classic toxicity, and after that you can perform additional clarification by our acceptability classifier. And in the end, the chance that dialogue agent is trained on something bad will be not so big. So yeah, it is highly recommended to use either our model or our data together with classical filtering approach. So all the results of our work are open sourced. The data can be found either on GitHub repository or in Kaggle. And the models trained on the data can be found in Hugging Face Model Hub in Skoltech domain. Yes, so this is it. Thank you for attention, and I'll be glad to answer your questions.
Thank you for your talk. I think it's time for questions. I've seen a couple of questions in the chat already, and I can ask the people in the chat to maybe read their questions out loud, or I can read them out loud. Well, it's up to you. What do you want?
Yeah, let me just read one by one, and maybe this will help me to understand it, because there is much text. Yeah, so first question is, mention a problem of human perception bias when comparison happens between multiple questions. 4 questions on one page with different level of problems. Later on page 18, you mentioned design classifier to address the perception issue. So did you use the to alter the mixing mechanism before submission to the local? Yeah, let me just try to understand more. Yeah, just 1 second.
I can maybe I can add a couple of comments on this question.
Yeah, maybe the one who wrote the question can.
Yeah, okay. Of course. Can we go back to maybe slide 16, 17, when you mentioned that
about some problems in 16? Yeah.
When we mention a problem, for example, in one sentence of binary classification, we compare, for example, selling drugs, and in another example,
okay, I understand what slide do you mean. This one, right?
Again.
You mean this slide?
Yes,
Yeah,
yes.
okay. So do you mean whether I used this heuristic and did I somehow prevent this problem, right?
Yeah, for example, use this heuristic in order to mix neutral and problematic examples before submission to Taloka, before secondary submission.
Actually, when we performed the binary annotation, we used the same clusters, which have been used for sensitive topics detected. So yeah, this is how we try to prevent this bias. Does this answer your question?
Probably yes.
I can follow up here. Could you please go back to this slide? So when you run tasks on Taloka, you can maintain the order in which the tasks, your texts, are shown to the users. And in this case, you can, and actually, in this order actually matters when you ask people to perform annotation, because if all the text you see as a performer on Taloka is gambling, you get used and you see some training effect. Otherwise, they are randomly mixed. You annotate one text about gambling, another text about suicide, another text about other things, and it might distract people. So in your case, what did you do?
Yeah, yeah, I understand. This is about this one, right? Yeah, actually, this was one so-called mistake, maybe for some future crowdsourced designers, it will be a good warning. So after this mistake, we understand that we should do like you said, like mixing and prevent not uploading the samples related to one unique topic to the task pool. Yeah. So this was a mistake, and we handled it, but it was just an insight which could probably be useful for someone who is fond of crowdsourcing stuff.
Yeah, it's a very cool insight that I'm really interested in. So yeah, and there is a second question from Evgeny, who said, for paywars comparison, what happens if a comparison of terrorism versus torrent, did you try to make it paired with probably neutral sentences to make such examples noticeable?
It's about pairwise. Did you try to make it paired?
Yeah, the pairwise comparisons.
Yeah. So you mean instead of directly comparing the terrorism with torrent, compare terrorism with something neutral and torrent with something neutral, right?
Yes, because in the previous case, when we compare terrorism against torrent, as you mentioned, of course, torrent is not so terrible, but it is also a bad thing in our case.
Yeah.
And if we will always compare it with neutral examples, they both will be somehow treated negatively.
Yeah, I understand. So actually, we, as far as I said, the Yandex Toloka does not have, as far as I know, after my dialogue with technical support, I understood that Toloka does not have the embedded features to perform all the process necessary to pairwise comparison. So to be honest, after spending some time for coding all this necessary stuff, we just in some sense foresee this issue, but it was not the main issue, but it was one of the last but not the least, so to say, issue. Yes, so we did not try to directly address it. Yeah, and as you correctly mentioned, both of the things are equally bad. But as far as I understand the idea of aggregation and of the ranking of pairwise comparison, it is in nature of pairwise comparison ranking to put something on top and to something to bottom. And yeah, this was the main reason why we selected the binary comparison, because it is easier and it maps everything in one single cluster, close to one. Yeah, it's a bit more information than you requested, but I hope I answered.
Actually, I didn't get. Is your binary classification is like multi-class or what?
Binary classification is
it's like can it prescribe the same instance multiple classes?
No, we collected two data sets, and one is multi-label, one is binary. So hence there are two classifiers, one multi-label, and it is not related to final binary classifier. So yeah, inappropriateness classifier only defines whether it appropriate or inappropriate.
I see.
I have a follow-up on this topic because when you perform such evaluation, so you want to perform pairwise comparisons, when you use Davidskin model or any other model which is based on latent label assumption, you explicitly assume that for any given question that you aggregate the answers using Davidskin, there is only one correct response, regardless of the subjective opinion of the performer. And that's the core idea of these methods. And in my opinion, it's not very safe to use confidence provided by the Toloka aggregated results for performing aggregation that you do. The correct approach here would be to use pairwise comparisons, which so basically what you want here, you have a set of items and you want to build an ordered set of these items. You need some ordering for which there are special algorithms that do not take this latent label assumption into account, and for which there are a few algorithms like Bradley-Terry and so on. And of course, you were correct about the lack of these algorithms available in Toloka, via click. So you cannot push the button on Toloka right now to access the functionality. But you don't have to, because we have recently published a library in Python, which is called Crowdkit, that implements all the aggregation algorithms you might want, including, of course, pairwise comparison aggregation algorithms, which is Bradley-Terry, noisy Bradley-Terry, and a few more like for aggregating both latent label assumptions like Davidskin, for pairwise comparisons like Bradley-Terry, and for text aggregation, which is Rasa, Rover, and so on. It has a lot of different algorithms that you might find useful. So you can integrate this library, which is available on Python package index in your code, in your production, and it would help you just to get this course. And its interface, allows you just to get some data frames and pandas. You obtain this course and you can use them in your application. So I think that should help you, and it would be methodologically sound.
Yes, thank you for the feedback. Actually, you said that it is not safe to use the confidence by Davidskin, but I believe that the insight about the quality of the model, which definitely depends on this confidence, shows that in this case, at least, this was okay to rely on the confidence.
Could you please clarify? So in my opinion, when you show 100%, for me, it's the same as all samples. What's the difference between all samples and 100%?
No, it is, maybe this axis was not correctly described. All samples means that percent here means the confidence of the sample. So not all the samples received the 100% confidence.
Indeed.
And some of them had the score some like 0.91 etc. So the more samples with lower confidence are engaged into the training process, the lower the metrics which we can get from the model.
I see. Yeah, it's like 0%. I mean, it's something like threshold. And
yeah, threshold. Yeah, if we define a threshold like everything which with confidence less than 70% is just dropped, so we will get some F score in this area. If we set the threshold in nothing but 100% confidence is used for training, we will get the F score in this area. So this is the idea. So I believe in this very case, Davidskin aggregation results helped us a lot.
But in my opinion, if you rely only on 100% confident responses, it means that most likely this responses have received all the same responses. So you have yes or no or whatever.
Yeah, yes or no. Yeah, in this case. Yeah.
In this case, which means that 100% most likely means that everybody clicked the same button.
Yeah. So this is so we used only the samples which are treated equally by all annotators. So, and this results in better quality of the model.
But I mean, you used, but it allows you just to use, majority vote that just counts the number of votes given for each label. So I'm not sure if the skin is really helpful here. Another thing that's not clear to me is which kind of averaging you used for your F-score. Is it micro or macro?
No, weighted. It was weighted.
Weighted by which kind of weighting?
Weighted as far as I remember by appropriate or inappropriate. So like that, like here.
The number of classes, the instances of classes. I mean.
Yeah, probably. Yeah. Now I can't recall it immediately.
Okay. So because usually, well, all those metrics are biased in some sense, and usually for me it's simpler to reason in terms of pure F-score or Matthews correlation coefficient or something that does not require this kind of averaging, because every time I see I use F2 score, I'm starting to ask questions like why don't the original measure doesn't work for you? Yeah, I got it. So and you say that if you use such a threshold, you have more confident results, and this is a classification task, right?
Yeah, binary classification task.
But when you use a very high threshold of 100%, is it correct that you have lower amount of data, right?
Yes. It's like what I said in this slide. In dataset statistics slide, I can. Yes, here. So yeah, this is the amount of samples after the thresholding.
Because maybe I'm missing the point, but is it fair to compare these models underweighted F-score if you use the different amount of data every time?
Different amount of data. You mean comparing this kind of comparison, right?
Yeah.
Well, when I use the threshold, I performed the key fault validation, so different splitting. So and I tried to show it on the plot that it has some plus minus some variation of the metric. So I believe that bearing in mind that this is the data from same nature, and I think it is fair to compare it. So this means that this is a subset of this is a subset of this, etc.
And when you were discussing and describing the data set, I probably have missed the slide, but do you have the balanced class distribution, or it's skewed in some sense?
Maybe this plot answer your question. But yeah, on this plot, it is necessary to emphasize that some samples can be related to several sensitive topics, but most of them are related to only one sensitive topic. Yeah, so I believe this plot somehow answers the question.
So you have a skewed data set in which you have the majority of responses are appropriate. And have you evaluated whether this affects the evaluation? So you have, you can say, I always respond appropriate. How much F-score would you have after that?
Yeah, I believe here is the answer. So I've shown the more detailed classification report. For inappropriate utterances, the metrics are quite lower. I believe that the reason is in the nature of inappropriateness, which is hardly to be detected with some clear features, like for example, in case of toxicity, you can understand that the phrase is toxic by some explicit keyword. And in terms of inappropriateness, it is not always clear why actually it is inappropriate. Yeah.
Because in your table, as far as I see, the simple baseline, which always says 0, which I think is appropriate, outperforms the sophisticated neural network that achieves a lower F-score. So it's fine because it can be explained. We have an imbalanced data set and so on and so forth. But when it comes to the not ablation study but error analysis, have you found the weak spots of your methodology? I mean, your model.
Weak spots. We used for this case we used standard Bergford sequence classifier from Hugging Face. So I think that we missed this stuff about weak points. If I understand your question correctly. So there is it was not some special architecture for this binary classification. So yeah, probably we did not do this some special researches on the weakness.
Okay, cool. Thank you very much. More questions, please. Let me check the chat. I think last message was mine. Okay, so I think if we have no questions, I propose to say thank you very much to the presenter, and we can say the seminar is over for today. Yeah, and for the next session, I think we will change the time slot in which the seminar takes place because it's quite late in Russia, but we are currently investigating when should the seminar take place. So if you have proposals, you can reach me. Maybe you have some ideas better than we and better than us, and we will be happy to hear from you. Thank you very much for the talk. Thank you very much for.
Thank you.
Thank you.